Hello everyone. In this video we are going to solve the problem number 1.18 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A point travels along the x-axis with a velocity whose projection Vx is presented as a function of time by the plot in figure 1.3. So this is figure 1.3, in which in the x-axis we are having the time and in the y-axis we are having the x component of velocity. And it is assumed that the coordinate of the point x is equal to 0 at the moment t is equal to 0. So at t is equal to 0, it is asking to assume that position at this point is 0 and the velocity component of in the x direction is also 0. Now draw the approximate time dependence plot for the acceleration, the x coordinate and the distance covered s. Okay, so let us first divide our entire domain in the plot as a subdomain. So let us say this particular point is A, this is the point B, this is the point C, and this particular point is D, and this point is E. Okay, and in all those particular region we will analyze the kinematic parameters such as velocity, acceleration and coordinates, everything. Okay, so let us first analyze those things in the region A to B. Okay, so in this region if we see that the slope between velocity versus time graph is constant, and we know that the slope in the velocity versus time graph gives us the acceleration. Okay, so if the slope is constant, then we can write the acceleration as change in velocity divided by change in time. Okay, and this change in velocity and change in time we can write between any 2 points in the region A to B. Okay, and delta V we can write VB minus VA whole divided by TB minus TA. Okay, and if we see the coordinate at point A, that is 0, 0, and coordinate at point B is 1, 1, and the x part of the coordinate is representing the time and y part of the coordinate is representing the x coordinate velocity. Okay, so from here we can write 1 minus 0 divided by 1 minus 0 is equal to 1 meter per second square. So this is the acceleration we have got in this particular region. Now let us write the displacement of the point. So we can write u into delta t plus half into wx into delta t whole square. First of all, this u is the initial velocity, that is point A in the region A to B. Delta t is the time interval between point A and at any point between A and B. Okay, so we can write from here velocity at point A into t minus 0 plus half into wx into t minus 0 whole square. First term is 0 as velocity at point A is 0. The second part we can write half into wx we have found out at as 1 into t square. So this is t square by 2. So this is the displacement in this region we have got. Now if we want to find out the position at any point in the region in between A and B, that we can write x is equal to xa plus delta s. So xa is equal to 0 as it is given in the problem. So the position we can write t square by 2. If we want to write the position at point B, that is x at t is equal to 1 second, that is equal to half meter. Okay, so this is the value we have got. Second, let us go to the second region, that is B to C. In the region B to C, we can see that the velocity at every point between B to C is constant. So basically we can say here that the velocity is constant. Okay, if velocity is constant, that means acceleration is 0, because delta v is 0. Okay, so that means we can say wx is equal to 0 in this region. And if we write the displacement, that we can write u into delta t plus half into wx into delta t whole square. So the velocity, initial velocity, in this case we can write vb into t minus time at point p plus half into 0 into t minus time at point b whole square. So velocity of b, we know that is 1 meter per second, and time instant at point b is 1. So we can write t minus 1, that is equal to t minus 1. Okay, this is the displacement we have got in this region. Now if we want to find the position at any point, that we can write xb plus delta s. What is the position at point b? From here we have found out as half meter, so half plus t minus 1, so we will get t minus half. So this is the displacement we have got in between any point in between b and c. Okay, and if we want to find the position at point c, that is equal to x at t is equal to 3, because time is equal to 3 is at the position of c, and then we can write 3 minus half, that is equal to 5 by 2. Okay, so this is the value we have got from here. Now let us come to the region C to D. In the region C to D, again the acceleration we can write velocity at point D minus velocity at point C whole divided by time at point D minus time at point C. And if we write the coordinate of point D, we can write from here the coordinate of point D is 6 comma minus 2. Coordinate of point D is 6 comma minus 2, and coordinates of point C is how much? 3 comma 1. Okay, so VD minus VC we can write minus 2 minus 1 whole divided by 6 minus 3. So from here we will get minus 1 meter per second square. So this is the acceleration value we have got. Now let us write the value of displacement, that we can write u into delta t plus half into wx into delta t whole square. So here the initial velocity will be vc into t minus tc plus half into minus 1 into t minus tc whole square. Okay, and C point is at the time t is equal to 3, and Vc we know that is 1 meter per second, so we can write 1 times t minus 3 minus half times t minus 3 whole square. Okay, so basically this is t minus 3 minus t minus 3 whole square by 2, and this is the value of the displacement. Now if we want to write the position at any point, that we can write x is equal to xc plus delta s. What is xc? xc is 5 by 2, so we can write 5 by 2 plus t minus 3 minus t minus 3 whole square by 2. So this is the position of any point in between C and D we have got. Now if we write the position at point D, that is x at t is equal to 6 second, then we can write 5 by 2 plus 6 minus 3 minus 6 minus 3 whole square by 2. Okay, so from here we will get 5 by 2 plus 3 minus 9 by 2. Okay, so we will get 1 meter. Now if we analyze the kinematic parameters in the region of D to E, then in the region of D to E, again we can write the acceleration is equal to velocity at point E minus velocity at point D divided by TE minus TD. Then we can equate it to the coordinate. If we write of point E is 7 comma 0, coordinate of point E is 7 comma 0 and of point D is 6 comma minus 2. So if we write the velocity, that is 0 minus of minus 2 whole divided by 7 minus 6, that is equal to 2 meter per second square. Okay, and if we write the displacement, that we can get u into delta t plus half into wx into delta t whole square. U is nothing but the initial velocity, that is velocity at point D into t minus td plus half into wx is 2 and t minus td whole square. Okay, so velocity at point D is how much? From the graph we can see at point D it is minus 2 meter per second. So we can write minus 2 times t minus, and here td is 6 plus t minus 6 whole square. So from here we can write t minus 6 whole square minus 2 times t minus 6. This is delta s. Now if we write the position, that we can write x d plus delta s. What is x d? That we have found out from here, that is 1 meter. So 1 minus 2 times t minus 6 plus t minus 6 whole square. So this is the position we have got. Now if we want to write the position at point E, then we can write x at t is equal to 7 second, that is equal to 1 minus 2 times 7 minus 6 plus 7 minus 6 whole square. So that is equal to 0 meter. Okay, now we have got the position and the acceleration in every subdomain. So let us plot all those things. Okay, so let us first plot the value of acceleration versus time. So this is the acceleration in the y-axis and time in the x-axis. Okay, let us say this is t is equal to 0, t is equal to 1, 2, 3, 4, 5, 6 and 7, and let us represent it as 1 meter per second square, 2 meter per second square, minus 1 meter per second square and minus 2 meter per second square. Okay, in the region A to B, we know that is from t is equal to 0 to 2 is equal to 1, and in that region the acceleration is 1 meter per second square. Okay, and in the region B to C, the time is from t is equal to 1 to t is equal to 3, and in that region the acceleration is 0, and from t is equal to 3 to t is equal to 6, the acceleration is minus 1 meter per second square, that is the region between C to D, and from t is equal to 6 to t is equal to 7, the acceleration is 2 meter per second square. Okay, so this is the acceleration profile we have got. Now let us come to the plot for the position. Okay, so this is the graph for the position. So in the x-axis again we are having the time, and in the y-axis we are having the position. So let us denote, this is 0, this is 1, 2, 3, 4, 5 and 6, 7, and this is the 1 meter, 2 meter, 4 meter, 5 meter and 6 meter. Okay, at point 0 the position is 0, that we know, and at point 1, that is t is equal to 1, and point B we have found out the position is half. So this is the position half, and the equation is t square by 2, so it will go like this, to time t is equal to 1, and at time t is equal to 3, we know the position is 5 by 2. So this is the position 5 by 2 at t is equal to 3, and the graph between time t is equal to 1 to 3, it is linear, and so this is linear, and at point 6 we know the value is 1, the value is 1, but from here it will not directly go to 1 because the equation is parabola. So that's why it will go in the upward direction and it will come back to 1. So let us find out what is the maximum, what is the time at which it is attaining the maximum value. So let us go to the region of C to D. So in the region of C to D, if we see this particular x, and if we differentiate dx upon dt is equal to 0, if we differentiate this one, we will get 1 minus 2 times t minus 3 by 2 is equal to 0. So from here we will get t is equal to 4 seconds. So t is equal to 4 seconds at which we will get the maximum value of the position. Okay, and what is the value of that position? If we substitute here t is equal to 4, then we can get 5 by 2 plus 1 minus 1 by 2. Okay, so the value we will get here is 3 meter. Okay, so if we draw the graph here, so it at t is equal to 4 seconds, it will go to 3 meter, and then it will come back to 1, and at t is equal to 7 seconds, again it is a parabola and it is coming to 0. Okay, so this is the approximate graph we will get for the position. Now if we come to the distance graph, then till t is equal to 4 seconds, at which the distance is keep on increasing. After that also it will keep on increasing even though the position is decreasing. So basically what is happening, it is going to the position x is equal to 3, then it is come back to 0. Okay, and it is the x is equal to 3 at t is equal to 4, and t is equal to 0, the position what x is equal to 0, and this is the case at t is equal to 7 as well. Okay, so that's why after this time t is equal to 4 seconds, the graph will increase in the upward direction, and at what value till then it will go to this particular position, that we can find out by adding all the delta s after this particular location. Okay, so this is the graph for the distance. I hope the entire procedure is clear. Thank you.